and answer a question for the annual exam from the 100 before things just after C practice this now. The most unique alarm question is compulsory down to that is a Gauss-seidel. I will give it very important. Now see, solve the given linear system by Gauss-seidel integration method. Is mx plus y plus z equals to x plus my plus z equals to 40. X plus 2y plus 10z equals to 40. So this is a problem. Now we have solved this problem by using the Gauss-seidel integration method. It means what? We have find the variable values. X, Y, Z variable values we have to find. So let's page 12. Iterations. First of all, the given term can be written as see here once again. See. The given system can be written as, for the first equation, we are going to take an outside x. Right? Equation can be taken outside the x. Taken outside the x. X equals to that is 5 minus 6 is here. For the second, I'm going to take an outside the y for the second equation. In the second outside the y, so that is equals to 1 by 10 13 minus 2x minus 6. X minus 6. For last equation, I'm going to take z. For the z, okay, that's z. 13 minus x minus 5. This is equation number 2 and equation number 3. And the concept of substitutions is Gauss-seidel. Okay. So what is the Gauss-seidel integration method? We are going to substitute the previous values in the further steps. So by Gauss-seidel integration method. Right? Now we go for the first step. The first step is nothing but what one here? First approximation. The first approximation is write it as approximation. Here the step 1. Step 1 is the first iteration or the first approximation. Right? Now, initially, the first approximation has zeros for y and z only. Initially, initially take the values y equals to 0, z equals to 0. These are the basic values. That means initial values are denoted with y of 0 and z of 0. Okay, next. Substitute these values in the x equation. So x first approximation can be written as, this first equation can be written as minus a. But in RHS, we substitute the approximations. These are called the approximations. Is it right? But in LHS1, RHS takes each. We substitute the 1 by 10 into 7 minus y of 0 get 0 to 1 by 2. So x first approximation value is 1.2. Okay. Then find the y first approximation in step 1. So the y equation as it is 1 by 10 into 13 minus 2x minus 6. Now see here again we need to change RHS. Y first approximation means we are going to substitute the approximation in x. But the last one, the last value is only. Substitute that 1 by 10 into 13 minus 2 into x first approximation 1.2. That approximation can see now this value is total, this value is 1.06 pH. Using the calcium. Finally, we are going to find z first approximation. 1 by 10 14 minus x minus 2 by the last x signed by 1 x first approximation. That is first approximation. Yeah. Now substitute values 1 by 10 into 14 minus 2 into x first approximation 1.2 minus 2 into y first approximation 1.06. Now and we can see I'm getting this value z first approximation is 0.948. It is the first approximation or the first iteration. Now we go to the approximation. Now the second step is second approximation or second iteration. Right? Now in the second iteration also, we are going to find the x2, y2, z2 values. Okay. Now, put x2, x1 value here. X1 value is 1.2, y1 value is 1.06, and z first approximation value is 0.948. These values we have to substitute in the coming approximation, that is a second approximation. In the step 2, we are finding the x2, x second approximation. As it is, we are going to formula right here 1 by 10 into 12 minus y minus z. Again, same procedure. In the right side, we have, let's say we have the 2. In the right side, we are going to substitute first approximations, the last values of yz, these only, yz, first approximation, 1 by 10 into 12 minus y first approximation, 1.06, z first approximation, 0.948. Okay, now by using the calci, the x second approximation value is, so I'm getting here this rate 0.992. See, this is the x2, x second approximation. and again going to find y second approximation. Take the y formula 1 by 10 into 13 minus 2x minus z. This is the actual formula by equation number 2. Again, we need to take the iterations or approximations in the RHS. For the second approximation, we are going to substitute x last value is the 2 and z last value is the 1. Here substitute 1 by 10 into 13 minus 2 into x second approximation 0.9992 minus z first approximation 0.948. Now using the cal C, I am getting the y second approximation 1.005. Okay. Finally, in the second step, we are going to find the z second approximation. Take the z equation 1 by 10 into 14 minus 2x minus 2y. Take the approximation in the right side. For the z second approximation, x second approximation completed, y second approximation completed. Right? So 1 by 10 into 14 minus 2 into x second approximation 0.992 minus 2 into y third approximation, second approximation. This is second, right? So 1.005. Using the cal C, I am getting the second approximation of z is 0.999. These are the two approximations. Okay. Maximum we have to do 4 approximations for the Gauss-seidel iteration method. Because of this is a very lengthy problem and this is a long question. Right? For the long question, only one question in the question paper and there is no substitution of a given one. Okay, so that's why we are going to use and find out the 4 approximation minimum. Okay. Now, then go to the third approximation, that is the step 3. Step 3 is third iteration. Third iteration. What is the third iteration? Again, same procedure. We are going to substitute the second iteration values. X2. X2 is 0.992. Y second approximation 1.005 and Z second approximation 0.999. So these are in the second step. And in the step 3, we find the X third approximation. So take the equation that is 1 by 10 into 12 minus y minus z. In the RHS, we are going to substitute the approximation. For the y, last approximation is the 2. For the z, the last approximation is a 2. So just to substitute those values here, 12 minus y second approximation 1.005, z second approximation 0.9. Getting by using the calculation, x value is 0.996. Right. Now find out y third approximation. So take the function or equation for the y second equation 1 by 10 into 13 minus 2x minus z. In the right side, we are going to substitute the approximation. For the x, last approximation is the 3. Right. For the z, the last approximation is the 2. This is the 3. Okay. Now substitute the values 1 by 10 into 13 minus 2 into x3. That is third approximation. 0.96 z second approximation 0.999. So by third approximation using the calculation, I am getting here directly 1 mark. And final in the given step 3. So we are going to find the z third approximation. I'm going to write the formula or equation for the z. So that is 1 by 10 into 14 minus 2x minus 2y. In the right side, substituting of approximation for the x last approximation is the 3. For the y last approximation is also 3. So 1 by 10 into 14 minus 2 into x third approximation 0.9996 minus 2 into y third approximation is the 1. By the calculation and calci, I am getting the z third approximation is 1. Now, here the third step completed. In the third step, I am getting x3 0.996 by 31 z31. Now, I am going for the fourth step. The fourth step is step 4. Fourth iteration. The fourth iteration, we are going to substitute the third step values. How many values in the third step? Both x third approximation is 0.996. Y third approximation is the 1 and z third approximation is also 1. Here these three values we are going to substitute in the fourth step. Here the fourth step values are now x fourth approximation goes to here 1 by 10 into minus y minus z. Now substituting the RHS approximation. For the y last approximation is the 3. For the z last approximation is the 3. So 1 by 10 into 7 minus y and z values are 1. Okay. Now by using the calcium, I am getting x fourth approximation is the 1. Now find out y fourth approximation. So 1 by 10 into here y equation 1 by 10 into 13 minus 2x minus z. For the x last approximation is the 4, z last approximation is the 3. Just substitute the values 1 by 10 into 13 minus 2 into x fourth approximation is the 1. Z last approximation is also 1, that is a Z3. Y fourth approximation, the value I am getting here, it is the 1. This is 14. I am getting here 1. Now, all the values are completed except the Z. Here we are going to find the last Z fourth approximation. For the Y, it is 13. For the Z 14. 1 by 10 into 14 minus 2x minus 2y. The RHS x last approximation is the 4. Y last approximation is the 4. Just subtract there 1 by 10 into 14 minus x fourth approximation, y fourth approximation is the 1. So 2 into 1 minus 2 into 1. So we get here z fourth approximation is the 1 using the calcium. See here now, I'm comparing any two consecutive approximation so that here x third approximation, x fourth approximation. See here, these are the approximate values. 0.996 is approximate to 1. So I'm considering this is the 1. Here y third approximation is the 1, y fourth approximation is the 1. These are also equal. Z third approximation is the 1, z fourth approximation is the 1. Now these are also 3 are the approximated values. Now I'm going to stop this procedure because of the two consecutive iterations, variable values are approximately equal. Then we can stop the procedure and hence we can consider the x value, z value, y value are the last step. Okay, now Hence, from step 3 and step 4, we get x equals to 1, y equals to 1, and z equals to 1 by Gauss-seidel iteration. This is the problem. This is very important problem, and you have to do practice more problems about this method. Compulsory question, don't neglect ma. And 6 we have the exam. Damn sure this question is appear in the paper ma. Please be careful and write the exam, all of you. Thank you.